table where it says temperature K. All right, so then it says the Clausius-Clapeyron equation may be written in several forms, but this is the most popular form of expressing Clausius-Clapeyron equation. It says if P1 and T1 are the experimental vapor pressure and temperature, which is what you see there, the T1 is
I hope not.
393.37 K. I hope you pulled it and you got a reading.
Chris.
And the temperature is, the pressure is 1.5 kilotons or 1,500 torrs. All right, so then.
Can you show me, is it the H2O in the lab book? Or, oh no, it's already there. Duh.
Do you see the lab picture on the screen?
Yes.
Okay. To the left of it, do you see? Let me put in, do you see 6.505 L?
Yes, I do. All the numbers are there.
Okay, so you see all the numbers.
Yes.
All right, so what is the question?
Oh no, nothing. I realized that I see it. I have everything.
You have everything, very good. All right, so have you pulled the lever for the temperature? That's the lever there. You pull it and then you write what it reads on that little table right in before number 3. So Chanel, do you pull it? What did you get? What does it read?
Well, if I'm moving the number.
You're not moving any number. You are pulling the lever. Can you see my cursor?
Yes.
Can you?
Yes, I can move that.
All right, pull it down. So what does it show on the screen?
It's not showing.
You got to show something. You don't just tap it, you pull it down.
Yeah, I'm pulling it down. It's not changing it. It's like clicking here. I can show you. Give me 1 second. Can I share my screen just to show it?
I just did it. You has to be, before you pull it, that thing has to look like hand.
Yeah, I'm pulling it. It's not moving. It's making clicking sounds.
Who else has that problem?
You have to hold it down. You can't like just pull it and let go. When you pull and let go, it makes that now.
Oh, I get it. Now I get it. Okay.
Well, that's when it says pull. Pull doesn't mean touch. It says.
I'm sorry.
Yeah, no, I get it. Thank you so much.
Okay, so what number do you see?
393.37.
Okay, all right. Okay, so that is the T1.
Okay.
And the P1 is that pressure, the pressure you see there, 1,500 torr or 1.5 kilotorr. So number 3 is telling you what you're supposed to do, that the Clausius-Clapeyron equation may be written in several forms. For this assignment, the most useful form can be written as shown there, natural log of pressure 2 over pressure 1 equals negative temperature of heat of vaporization over the gas constant into 1 over T2 minus 1 over T1. And when we did this type of thing last week, we said it would be nice to rationalize the things in parentheses first, and then you can make what is being asked for as the subject of the equation. Some people were able to just do it right away without putting in number, and then after they met T2, the subject in the equation, then they start substituting, which is elegant. All right, so the question says for you that you measured that the pressure at the top of Mount Denali, which is the mountain in very close to Seattle, Washington, the P2 is 340 tall. All right, so now you have the P2 over P1, you know the values. That the boiling point of water, T2, at the top of the mountain can be calculated by solving that equation of Clausius-Clapeyron. And these are the things that are given to you to help you do that calculation. That the value of R is 8.314 joules per Kelvin per mole, and the heat of vaporization of water is 40.67 kilojoules per mole. In other words, the only thing you don't know there now is T2.
Yeah.
Right?
Yeah.
All right. So I have kind of put these things together to help you with the first and second step of the substitution. All right, so you can see the equation there. This is the equation it gave you, the Clausius-Clapeyron equation. Remember there is a negative minus sign there, and this is
can you
sign.
pull the whiteboard a little bit closer? The glare of the window is making it a bit blurry.
Did it disappear?
Yeah, thank you.
Okay. All right, so the P2 in our question is 340 tall. The P1 is 1500 tall. And then you put in this change, what do you call it? The heat of vaporization of water is 40.67 times 10 to the 3 joules. What he gave us was, he gave us kilojoules, but we changed this to joules so that the J's can cancel out. And then the gas constant is Kelvin per mole. So because they're going to be under here, then they become on top.
Well, hold on one second, Professor. The 40.67 kilojoules / mole.
Mm-hmm.
I'm trying to see it, but it's blurry. So if you could pull the board up. So I'm trying to see what's at the bottom of that.
What is blurry about it? The number or the value? I mean,
probably the number, not the number, the one underneath that. What does it says at the right there? No, go down. No, go down. Right there, yeah.
MOL.
Mole, okay.
And that mole cancels the top mole from the R.
Okay.
So now you've put in everything that you know. And this is the one you don't know. You make this the subject of the equation, and you multiply, divide, and cancel out, and you get your answer.
And you have K times mole, or what is that?
Which one? Over
The
here?
yeah.
Okay. Temperature in Kelvin times mole.
Okay.
Remember that the units of the gas constant is 8.314 joules over Kelvin over mole. And because this thing here is under that, if you place this under this, then this K mole will be on top.
Okay, question I have, I hope I say it right. Hopefully I say it right. The moles cancel out because the mole is at the bottom of 40.67, right?
Yes.
So my moles cancel out, right?
Yeah.
And then the K cancels out, right?
This K?
No. The joules. I'm sorry.
The joules, yeah, the joules cancel out. Remember in the question gave it to us in kilojoules, and 1 kilo is 10 to the 3.
Right, but if that's it, ain't that supposed to be a K right there though? 40.67.
Yeah, well, what I know, what your question is what I just answered. That the question asked in kilojoules, and that K you're asking about is kilo, which is 10 to the 3,000. It's not the same thing as this K, which is temperature.
Okay. So 10 to the 3. Okay.
So it says kilojoules squared to the, kilojoules squared.
Where did you see square?
Well, I can't really read what you wrote, but where it has the 4067 times 10 to the 10, right?
40.67 times 10 to the 3 joules. J.
Okay. Thank you.
So since the J's canceled out, right? And still at by the 8.314, did it leave the K there or no?
That's the K that was in the question before?
Yeah.
No, that's this 10 to the 3.
No, wait, I don't know. Maybe I'm mixing it up. I don't know.
So it's 10 to the 3rd, right?
Yeah.
Okay.
So
it's just that the writing is small, so we keep asking the same question. We can't really.
The writing is small, but it is copied right from the handout which you have.
Well,
this thing here is 40.67 kilojoule. And because it is kilo, this is the same thing as saying times 10 to the 3. And so now the joules can cancel out.
Yes, I got the joules canceled out. I understand that part. It's just that.
You know what kilo means?
Measurement?
Kilo. Kilo is 1,000. And so 1,000 is the same thing as 10 to the 3.
Yeah, okay. So the joules canceled out. Then we went to the next equation with the parentheses, which is the 1 over, because we don't have T1.
You don't have T2. You're looking for...
we don't have T2, but we have T1, right?
Yeah.
I'm trying to find it. So it's one over one.
One over what?
Hold on, I'm reading the equation. 2. Confused. Plus K. Oh, wouldn't it be the 393.37 K? Or no?
Yeah, 1 over 393.37 K. That
Right? That's
is T1.
T1, right?
Yeah.
3. Uh-oh. I have to write slow. Hold on 1 second. Okay. And then T2, that's, wait, yeah, T2 is what we're trying to find, right?
That's what we're trying to find, yeah. And please do not just punch the whole numbers in your calculator and give me an answer. I want to see it stated step by step.
If, They wrote it a little bit smaller.
I'm just going to get out of stop share so that I know those who are here.
Okay.
But somebody logged out. So Shante, is your answer, are your questions answered now?
Sort of. I'm still, I have, well, since my hand is kind of toe up, I'm trying to make it a little smaller so I can really look at my problem on my paper.
Okay.
And then, yeah.
And you know you can also express it on a new clean sheet of paper.
Right.
That's
I just didn't feel like getting up.
That's exactly how my sister-in-law says, right. Right. Then I'll say,
I'm just being a little lazy, Professor. I don't want
to that. Okay, so any other, Nora, do you have a question? Or you are processing it?
I'm trying to figure out how we're going to give it to you step by step.
Just like you write, in fact, come to think of it.
Oh, I see it a little bit, but not really. But
even the space is enough to solve the problem and give me a step by step and the answer. And if you don't want it, which is what some of the people in the morning did, was just to copy this on a paper and just do this and number 3. But the important, no matter how you did it, all I want to see is a step-by-step calculation that will give you the answer of the T2 in Kelvin. Then if you want to, you can change the Kelvin to regular temperature, but it's not necessary because everything is being given to you in Kelvin.
Okay, question.
Yeah.
The K that's on top. Huh? I don't know what they're saying. Okay, the K that's on top of 8.314.
Yeah, that is the unit of the gas constant.
No, I'm asking about the K.
Oh,
Would
that
that
K,
K,
that,
that
that K
K,
is not canceling out.
that's what I was going to ask you. Yeah,
It's not canceling out because it will, you'll be,
it's too far, right?
yeah, it's gonna be, it's taking care of these Ks.
So what is the process we would need to follow in order to solve for T2?
All right. The process you're gonna do is to make T2 the subject of the equation. And this is what you learned in algebra 125.
So, okay, I'm gonna ask you this question. If we, okay, I'm trying to figure out how I would ask it, but
Okay,
wouldn't it be,
about how to ask it.
yeah,
Now you're not thinking. You just accepted.
um,
So Chanel, can you work out this and find out what number it is?
Yeah, that it's gonna take me a little while.
It's
Like,
not going to take you any. It's not going to take you any little while. You punch in 40.67 times 10 to the 3 divided by 8.314. It's not going to take you any while for anything. Now somebody is coming in and going out. Ezra again.
okay, hold on, let me go get my calculator. I think I don't have. Oh, Jesus.
You have to have a calculator at least that can do scientific notation.
okay, and then I'm sorry, next to the triangle, what is the symbol or the letters written in between that, the triangle and the P?
Which triangle?
It's like
Over there,
yes.
that is this number here.
Okay, let's see what we got here. Okay, so if I do the 40.67 divided by the 8.31.
40.67 times 10 to the 3.
Yeah, I'm sorry, I forgot about that. 10 to the 10 to the 3 divided by 4. I don't know if that's right. That don't look right.
Why doesn't it look like right? This is 40,670 divided by 8.314.
Well, I got 4891.74887.
All right. So what makes you think it is not the right answer?
The decimal point.
Okay. Then you put it to the nearest whole number.
You said the nearest whole number. 1.
Either to the nearest whole number or to one place of decimal.
Sorry.
So if you put it to one place of decimal, what will this give you? Call it out.
I can't see. Your head is in the way.
No, just call it. You already divided it. You call out the number you get. You
okay. The one that I got was 489 1 point
489
1 point 748857.
All right, so maybe you can work with 4891.7. And this multiplying that parenthesis.
Huh? I can't see it. 489. Yeah. 4891.7. Yeah, because it can't get rounded up. So yeah, I see what you're saying. So it'll be 489.7. So since we did that part, and it still will be equal to 340 tour, and then over the 1500 tour.
Yeah. So you can divide that out. Those are real numbers. The tours cancel out, of course.
Hold on.
And that's
Yeah.
that's how we come to get this number.
Okay, hold on one second. And for that, it was 0.22. I say 227 if you round it up like you did, right?
Yeah.
Equal to 489.1.7. Yeah, because those canceled out, so that's it. And then 1 over T2 minus 1 over 39337K.
No, it's 393.37K.
Uh-oh. You said 393.37. Yeah, I'm sorry. I did put the point there. I just didn't say it. 393.37K. Yes. Now I take the 4891.7, divided it. I mean, is it divided? No, multiply it in. Is it multiplying or dividing? You get what I'm trying to say? No?
No, I don't know what you're trying to say.
Don't we have to multiply the 4891.7 into the equation in the parentheses?
Yeah. Okay. Yeah. That's right. This,
Okay, so,
this can go here and that can go there.
right.
All right. So
Okay,
now you only have one unknown.
Yeah, I'm almost there. Not quite, but hey.
Very good. Very good.
Okay. I got to remember how to do that. So that would be 0.227 equal to, if I multiply that into this, it's going to be 1. So that would be 4891.7 over T. I think it's T2.
Yeah.
Minus 4891.7 under, I got to just do those two. 4891.7. Well, that would still be I can't remember how to do it, but
what can't you remember how to do?
Yeah, so sorry.
It would kind of be a negative because the minus is there.
Yeah.
Remember, there is a minus here and a minus there.
Oh, it's minus on both of them? Oh, I didn't put that. Oh, shoot. I messed up then. I got to go all the way back.
Okay, so the 393.37K, that is T1 or T2?
It's T1. How could it be T2 when T2 is here?
Okay.
See, I didn't know that was a minus there. So I got to go all the way back up to see if I did the problem right. See, now that I know that you said that that's a minus there, my problem changed.
All right.
And I don't know if it's a IN or the LN. Do you do anything with that individually?
Well, think back to the lab we did last Wednesday. where you saw something like that, what did you do with the ln? You have a calculator that has ln.
I'll grab it right now.
Professor, I think I did something wrong, so now I gotta like go all the way back. But
What did you do wrong?
I forgot to put the minus 40.
The minus, okay.
Yeah, so I got another different answer, which was my negative 343022.1289.
When you divided this by that,
Yeah.
now this negative sign wouldn't have anything to do. This is multiplication.
Okay.
That negative sign should come here.
At the bottom.
Yeah. That this, when you divide this by that, the negative sign comes here, it becomes negative 4891.7 into 1 over T2 minus 1 over 393.37.
Okay. So if that becomes a negative. Okay, hold on. Let me keep dropping things down. That means when I multiply the negative 4891.7 into the 393.37, that becomes positive.
Yeah. So then this becomes negative here, and this becomes positive there.
Okay.
Yeah, you remember your algebra. That's good.
Yeah, I remember it. I remember it, but a little struggling, not much. I'm a little struggling, not much.
Well, that is the thing. You know, keep struggling, but don't lose hope.
No, I'm not. I gotta pass.
Yeah.
Okay.
That's the right attitude.
I did something wrong. I ain't gonna lie.
And if you're writing it step by step and you think you've did something wrong, you go back to that thing and see what do you think you have done wrong, and then you correct it. But if you were doing it mentally, then you don't have anything to cross-check.
No. I'm writing it down.
All right.
Okay. I don't know if I can explain it to you, but I'll try. I have the negative 4891.7. I multiply that into the 1 over T2. So that would be a negative 4891.7 over T2. Then I multiply the negative 4891.7 into the 1. That gave me plus 4891.7. Then I multiply the negative 4891.7 into the, I guess you could say, minus the 393.37. And what I got was 1924248.029.
All right.
So when I drop the equation down, I have 0.227 equal negative 4891.7 over 2.
Negative what? Remember that the
It's the whole equation there.
0.227 has natural log in front of it.
One more time.
That 0.227 has a natural log.
Yeah. In front or behind?
So you're gonna convert that 0.227 into real number by pressing natural log on your calculator.
You mean those little squiggly lines?
No, it depends on the calculator, but it has an L and an N right next to it.
Yeah, very good.
Mine's have a LOG, but I don't have a LE.
No, that's LOG is next to that LN.
Yeah.
Oh, below it. Yeah, mine's below it, LN. So what did I do wrong from
No,
Which,
because you haven't taken into consideration that LN, natural log.
so,
You have to convert this number,
0.227.
7,
Okay. I guess that would be the minus 4891.7 divided by, oh, I don't know what's T2 yet. So I can't even put it in until I figure that part out. Right?
I think you're doing all right.
So wait, do we convert LN before we do the other side, or it doesn't matter?
It doesn't really matter.
So when I enter it into my calculator, do I push LN and then put 340 over 1.500 and it should give me 0.227?
Yeah, we divide out 340 over 1500. It will give you 0.227. Then you press natural log, and it will give you a number.
They didn't give me a number.
Oh yes, you will.
I put 340. Okay, hold on. Let me put it.
No, divide out 340 over 1500 first.
Yeah,
It's not 1.500?
1,500. We divide out first. That's how you got this number.
No,
yeah,
I know,
I
but
got the number.
Is
And
it
then
1,500 or is it 1.500?
1.500.
Oh, okay.
Is that what you got when you put natural log of 0.227?
Huh? I thought it was 1.500 too, but it's 500.
No.
You 340 taro over 500 taro, right?
Yeah,
I got 1.500.
over 1,500 tau.
Right. When you divide that, you get 0.226 or 227.
Okay. Then you take you hit natural log in
Okay.
your calculator. What does it give you?
It gave me nothing. It's just the LN with like one parenthesis, and it's waiting for me to enter something.
You put in 0.227.
Uh-huh.
And you should hit the LN function.
Yeah, my calculator worked that way.
Yeah, well, that I don't know your calculator. The regular calculator, if you put in 0.227 and hit
It just gives me it gives me a negative 1.48280526.
All right. So now, how did you get that number?
By pressing LN, put in 0.227.
All right. So you're not okay. So your calculator is you put in number. Okay. So
Yeah,
that should be negative 1.483 if I make it to 3 decimal places.
So negative 1.483 equal to a negative 4891.7 over T2 plus 4891.7 over. I still have to do that part over
You should
again.
have divided it out by now.
I did, but I forgot to write it down. So I have to my bad. I'm slow too.
Since she forgot to write it.
I forgot to write it down. You know, sometimes you get excited that you know what you're doing, and then all of a sudden you forget. That's
Well,
me.
that's why I said you write it down, and if it doesn't look right, you then look and see what you have written. Maybe instead of writing 8, you wrote 9. But if you don't write it down, it means you're gonna go way to the beginning of the thing to start tracing it back.
Oh no, I know where I left off at.
All right, okay.
So I have the 1924248.029. That's what I got. 1924248.029. Oh, that's long. Okay. So then once that was done, let me scoot my paper over. Like basically the top cancels itself because it's a negative blah, 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 blah. I want to keep on saying it, plus the 4890. That cancels itself. So that leaves me negative 1 point. Don't laugh at me, Professor.
I'm laughing. We are having fun.
Well, negative 1.483 T2 plus the 1924248.029. Now, correct me if I'm wrong, but if I minus that long number and bring it to the other side, that leaves the T2 by itself. And then I solve for my problem, which may be in a negative form, something like that. I know it's something like that. Something like that. Hold on, let me see. I don't know. Let's see. Minus that here. That'll be negative 148 minus 192. So, which would equal a negative 192,573.1.029.
So eventually you're going to get
T2. Oh, you said eventually gonna get a positive number?
Yeah.
Well, I guess because the only reason why I need a positive number because I minus this 1924248.029. I minus that and put it to the other side with the negative 1.483. So that's probably the reason why I didn't get a positive number.
Well, if you keep your science your algebraic science as you go ahead, then you should be able to see what's going on.
Oh, I see what you're saying. It's supposed to still be a plus.
Yeah.
But if I keep, okay, oh, wait, hold on. Well, I did keep it the same because it was still a negative 1.483 equaled. Wouldn't it still be T2 plus 1924248.029? But if you want to keep the T2 to the side that it's on, then something like that. I just can't remember how to do it. So am I right that at negative 1.483 stays the same, right?
Yeah. Negative 1.483 is the natural log of 0.227.
Right. But it's a negative, correct?
Yes, it's a negative.
So that will be equal to T2, right? Plus the 1924248.029. But if I subtract that 1924248.029 and put it to the other side with the negative 0.483, that gives you still a negative. It won't give you a positive. If I subtract, so I
Well,
can have the T2 to itself.
if you have done that, bringing the 4891.7 inside the parentheses, then that over T2 should be negative, and 4891.7 over 393.37 should be positive, because negative times negative gives you positive.
Uh-oh, I must have lost my own self then. I never, well, I don't know if I show it, if you can see it. Let's see. Let's see if I can show it. I don't know how to do it. But... They have a whiteboard.
Yeah, they have a whiteboard. So share screen and go to whiteboard.
Okay. Share screen, go to whiteboard. This is whiteboard, right? I'm on the whiteboard.
Yeah, that's the whiteboard.
Okay. I'm gonna try my best. You know, I'm working with one hand.
I'll have the patience. I'll be listening.
Okay. This ain't gonna work too good. Okay, if I do it the text, it might look ugly. I'm just gonna start it from right here. Oh, that's gonna look ugly. Hold on. You know, I could put my touch screen on here, but I don't know how to touch screen it. But if I'm gonna start at this point, 0. Oh no, I don't want to start there. I'm gonna start at negative 1.483. I want equal. Negative 4891.7. Only thing is, I don't know how to put the division on here, but.
Well, use that slash,
slash. Slash, yeah, the slash. There you go. Slash T. T2. That's the T2, I can make it small exponent 2, but plus 489.1.7 slash 1.248.029. And you see where the negative 4.891.7 and the plus 4.891.7, those two cancels out. So if you drop those, you would get the negative 1.483 equals to T2.
So, Shante, how did you get 1924248.029? What is that?
I told you from the other, let me see if I can put it somewhere else. Hold on, I'll show you. Because I was asking you if I was doing it right. Let me see if I could do another one here.
Because all these numbers we have, there is nowhere we can ever get that number.
Okay, I'm gonna try to show it to you. Okay. 0. I'm gonna go back a couple steps. 227 equal the negative 4.891.7 parentheses here with the 1. God bless you. 2 minus 1 slash 393.37 right here.
Uh-huh.
Well, it don't make sense, kind of, sort. You know how I take the negative 4891.7 and you multiply it in. So
Yeah,
when
then you multiply in, which means this one here will be 4891.7 over T2
yeah,
minus 4891.7 over 393.
okay, so I did that part wrong. So this will be changing here.
Yeah.
I don't know how to
Is
get back
it
to this.
positive since it's a
Yeah, that's what I
negative?
said. I got positive.
Yeah,
Because
so
it's a
when you
negative.
when you take the one inside, then will be positive.
How do I get back to this equation down here? Okay, I don't know how to get back to that.
Well, put your cursor there and go backspace thing.
Oh, select. Okay,
Yeah.
I'm gonna select this back. Okay, so if I did this, so this is wrong. I messed up. Okay, that's what I
Okay,
was trying to
so
ask you earlier, and
that
we
will be
like
393.37, I think. Yeah.
reset. Okay, bam. But that will be plus
That will be plus, yeah.
because the first one's negative, the second one is plus. Okay, hold on. I gotta redo my calculations. I see I messed up.
I'm not going anywhere.
Okay. So that's 393.
Is there any other person in the group, in the Zoom that has this problem? Need to rationalize it?
I'm just following along, so I'm learning
Okay.
as I go.
All right. Okay. That's
Perfect. 393. Okay, so this is where I think this is where, okay, after this part, I got stuck here.
all right. So, Shante, 4891.7 divided by 393.37. Those are real numbers. Get a number, get a value for that.
You said get a value for that?
Yeah. Divide 4891.7 by 393.37.
Okay, that's probably okay. 12.435366619.
Is what?
12.435366619.
Okay, so we take 12.435. Okay.
Hold on.
So when that plus 12.435 goes to the other side of the equation, it becomes minus. Then you're going to have minus 1.483 minus 12.435. You're going to get a number which you will then divide into T2.
Well, if
Go ahead. Don't get frustrated. Don't do
I'm
that.
about to get frustrated. I'm trying to keep a good spirit about this, but so it will be because I'm trying to do step by step.
Yeah, that's what I suggest. All right. So I didn't want to go and do it for you.
No, don't do it for me. I'm about to. No, don't do it yet. Don't do it.
Okay. All right.
I'm gonna give you the answer in a couple seconds.
Good. Adriana, so what are you following?
Yeah, right now I have negative 4891.7 over T2 plus 12.435.
That's what I got.
And do I just add it?
No, when it will be negative 4891.7 over T2 plus 12.435. Okay, so then that number is equal to negative 1.483, which came from the P2 over P1. So then, if you have that as your final unknown relationship, when you move the 12 plus 12.435 to the other side of the equation, it also becomes a negative. So then your final working formula will be negative 4891.7 divided by T2 will be equal to negative 4.483 minus 12.435, which will come to be equals 13.918. So then T2 will be negative 4891.7 over negative 13.918. The negatives cancel out and you get a number.
Yeah, I'm just like where I'm at.
Where you stuck.
Shantae, can I share my screen? So
I don't know how to stop it.
On the top, it should be like a red option that says stop.
Share.
Yeah, there's something that says stop sharing.
Okay.
Let me
blow this up so I
share
can see.
something.
Yeah.
You see, you guys have been able to reduce a complex formula to a simple linear formula.
Right.
So this is what I have so far. And
all right, okay.
Hold on.
So, all right, so then this one here, oh, shoot. All right, you see a negative 1.484.
Negative 4.
This one.
I don't see, I can't see you.
That's that number there.
Which one?
See my cursor?
No, we can't see your cursor.
Two cursors.
Oh, there we go.
Okay.
Well, this is me. So are you talking about this part right here?
All right. So then what is happening is when this number that's above your shade, there is a plus 12.435, right?
Right.
Okay. So if that particular 12.435 goes to the other side of the equation,
okay. That would be a negative.
It becomes a negative. So negative 1.484, negative 12.435 becomes negative 13.918, something like that.
Mm.
So
no, no, that is correct.
Oh, that's correct?
Yeah, over T2. This is equal to negative this and negative this will give you negative 13.918 over here.
So wait, if and then you're saying to
just switch that. Okay, 12, okay, 435 minus 12.435.
Like that. That's what you're saying, right?
Yeah.
Yeah. Because when it comes to the other side of the equation, it becomes a negative sign.
And then that would be 13. I think he said
13.9 something, 13.918, 918 or 919, something like that.
I got.
You're not gonna get anything more than that. All right. So now T2. Is
that correct? Is it negative?
Yeah.
Okay.
Now T2 will be equal to negative 4879.65 divided by negative 13.919. The negatives cancel out and you get some kind of number.
The negatives just cancel out like that?
Yeah. Negative divided by negative. It's like negative multiplied by negative. They cancel out.
How would you solve for T2 if that's underneath the 4,879? If that's underneath, then how would you switch the number?
You times it?
Yeah. No, that's
Chanel, what was the question?
Because it says 4,879.265 over T2.
T2.
So if the T2 is underneath that, then how would you switch that with the negative 13,999?
It's like you cross multiply. When you cross multiply, then negative 13.919 T2 will be equal to negative 4879.265, from where we get that T2 will be this number divided by that number.
Okay, so
We
the
fell off.
next
Are you
13.
saying like going like that?
No, don't go, just over here. If you multiply, this will become 30, this, please take those numbers out.
I did.
All right. This, this is conceptually the same thing as saying negative 13.919 over 1.
Yeah.
So if you cross multiply, then you get
Like that.
13.919T2 equals negative 4879.25. Is that, is that 4891.7? How did you change this to that? Anyway.
Wait, did I just write it down wrong, maybe?
Yeah, this number here, I think it should be negative 4891.7.
Yeah, she had it backwards.
Yeah. So when you cross multiply, then could you write down here that negative 13.919 T2 equals negative 4891.7.
You wrote it wrong again. 489. No 7.
4891.7.
Oh my goodness. I don't know what too many numbers.
Okay.
4891.7.
Negative.
Negative 48.
Yeah, okay.
917.
There you
All
go.
right. So in which case the T2 becomes that number divided by this number, negative 4891.7 divided by negative 13.919. The negatives cancel out, and you're gonna get about 300 and something there, equals blah blah blah.
Right. Well, you didn't do it for us, Professor. We did it on our own. You just
I know. All I did is to enjoy the work.
Thanks. I hope you like the color coordination. So I got, wait, it will be positive, right?
Yes, because the negatives cancel out.
This is what I got.
Yeah, well, the period after the first 4.
Unless I wrote it down wrong.
Well, you wrote it down wrong. It was negative 13.918. Yeah, not 919.
What? Oh my god! I'm just writing all these numbers.
Yeah, all the numbers.
It looks like the variation is in the decimal numbers. But right. Chanel, do you see how the thing is going on?
Yes.
All right.
But I messed up somewhere. I just did it on a different piece of paper.
4, 8, 9, 1.
All right. So Jessica, do you see what happened?
9, 1, 8.
Yeah.
Mm-hmm.
All right. So
so wait, that's what
Sitali, did you see what happened?
Yeah, I get it. I understand.
All right. And Ocampo, do you see what happened?
Yeah, I understand it.
Okay, Alyssa?
Yeah, thank you.
All right. Dervin? Are we singing the same song?
Yeah, we are. We are.
Okay. So when I mean step by step, this is what I'm expecting to see, so that if somehow you now get a very weird number, you can go back and see what you did, whether you have put in the wrong number, the wrong decimal point, or things like that. So all is this did is to reduce that initial formula to such a step where it has only one unknown. And then you can divide into a number to get the value of the unknown.
Wait, so did I get the answer right? Because apparently my numbers are all over the place. I don't know if my answer is correct.
No, Adriana, your number is not all over the place. It's there. When it was all over the place was when you said 4817 or something like that. But right here, everything looks okay, and that's bearing whether you are rounding off before dividing or something like that. So basically, I think what I got is about 351.9 Kelvin. 351.9 K.
9K. Where do you get the 9 from?
Well, because if you are rounding off as you're going, then there will be difference in the final number.
Okay.
Is it okay if it's close to it, or does it have to be?
All I want to see is 3 significant figures, because that's what most of the things are.
Oh, the 351.
So
you have 3 significant figures.
So would it be 352? Since this
it should be 352 if you get the same 351.9. 352 with the unit Kelvin. Without the units, it could be dollars, which would be wrong.
Right.
Okay.
Well, we did a good job. Teamwork is streamlined.
Yes, you did, and that's all it means.
Sorry if I gave anybody a headache.
All it can is that you kind of became more confident as you're going.
Right.
So that trepidation just went away. You were not scared to be wrong.
No.
You got it wrong, then you went back and checked up. That
right.
is all I ask for you guys to do. Don't get it wrong intentionally, but if you get it wrong, you will go and find out where it is wrong and then correct it.
I guess the older you get, the wiser you get.
Yeah, actually, that's true. Except that when you get, way downhill, then the wisdom starts going away.
Right. Well, now all we have to do is put it on paper all over again. You should see my paper. Okay. I think we're okay for today. This is a good
one. That's it. So all you're gonna do just maybe you just cut off number 2 and put it in the table and then copy it into a paper and show how you did all this work.
Right.
With the right unit as your answer and the right significant figures.
Okay.
That is the lab.
Okay.
Tomorrow's lab is Boyle's law. And because there is a lot of operations in that, I would suggest you print out the instructions, study it, so that when we come, we don't stay here until 8 p.m. clicking the wrong thing.
Right. It's a lot. It's a lot. It's 2 pages.
Yeah. And you're going to complete those, is that 2 or 3 tables?
Yes, 3 tables.
3 tables. So you can, well, when your kids go to sleep, you can use it to relax.
I don't know about that. I wake up early to do it like today.
I'll wake up early.
Yeah.
And I know what kids do. I don't know. Well, you guys are little children. I don't want to say what I want to say.
Well, some are little children. Correction. Not all. I did my time, paid my dues. Ain't going back.
Yeah. While the kids look for their mom, they don't see, they start going through every room, everywhere to look for her. And then they see her, they get satisfied.
Right.
Maybe there is nothing they want, it's just that they want to see their mom. Isn't that wonderful?
Yes, it is.
Yeah.
The worksheets, Jessica, I don't think we can really link it.
You don't think you can do what?
To link the worksheet. We found it okay. No problem. All right, Professor, have a good day. I'm signing off.
All right, good. So I'm glad we got something accomplished.
Yes, thank you. Have a good day. See you tomorrow.
See you tomorrow.
Bye-bye.
Professor.
Yeah.
Thank you.
You're welcome. You're welcome, Jessica.
Have a great one. Bye-bye.
Bye.